Right, look at the last topic, which is solving system of linear equations using Gaussian elimination method. So look at the second paragraph. Gaussian elimination is done by transforming the system augmented matrix into row echelon form using elementary row operations. Then the solution to the system is found by back substitution. Okay, I'm going to explain this using example A. Okay, so this is from question A. Okay, so this one is linear equation. Okay, we need to transform into augmented matrix. This one. Okay, I have done transform into augmented matrix. It will be the matrix A slash with matrix B. Okay, this one is matrix A. This one is matrix B. So we have done transform into augmented matrix. Okay, it will become the matrix A slash matrix B. Okay, and then from this augmented matrix, we need to convert into row echelon form. Okay, to solve the value for x1, x2, x3, we need to convert from augmented matrix into row echelon form, which is we need to make a leading one for the diagonal matrix, and then this one it is value, this one it is 0. Okay, we need to make a 0. Okay, we need to have a 0 value, all this 0 value below the diagonal by the leading one. Okay, so that means this one, -7 and 2, we need to make a leading one. Okay, make a leading one. And then for this value, 4, 2, -1, we need to make a 0 value. Okay, you faham now? So by using what? By using elementary row operations. Okay, so we have 1, 4, 2, -2, -7, -1, 2, 3, 2, 0, 0, 0. Okay, so we need to solve this one by using elementary row operations. Okay, because of this second row and the third row, 4, 2, the first step we need to make this 0 value. We need to make this 0 value. So because of this is positive 1, so positive 1, positive 4. Okay, because of this is positive 4, so -4 multiply with row 1. Okay, kita nak jadikan dia 0 value, kita tengok pada leading one atas dia. Okay, leading one atas dia, so kena darab dengan the first row, plus with row 2, it goes to the row 2. Okay, and then because of this is positive 2, okay, so we need to multiply row 1 with -2 plus row 3, it goes to the row 3. Okay, so we need to solve. Okay, so we need to solve this one. Okay, row 1 multiply with -4. Okay, boleh nampak dah? Okay, row 1 multiply with -4. So -4 times 1, we get -4. Okay, so -4 times -2, we get positive 8. -4 times 2, we get -8. And then -4 times 0, it is 0. Plus with row 2 here. Row 2 is 4, -7, 3, 0. 4, -7, 3, 0. Then you need to solve -4 plus 4, you get 0. 4 minus 7, you get 1. -8 plus 3, we get 5. -5. Then this is 0. Then it is goes to the row 2. And then the second operation here, -2 multiply with row 1. So -2 times 1, we get -2. -2 times -2, we get positive 4. Okay, -2 times 2, we get -4. -2 times 0, we get 0. Plus with row 3. Row 3 is 2, -1, 2, 0. So -2 plus 2, we get 0. 4 minus 1, we get 3. -4 plus 2, we get -2. Then 0 plus 0 is 0. So it goes to the row 3. Okay, then we can find the new value for row 2 and row 3. 1, -2, 2. This one is 0, 0, 0. So this one is 0, 1, -5. This one is 0, 3, -2. 0, 3, -2. Okay, the first row it is fixed value. Okay, yang berubah adalah row 2 and row 3. Okay, boleh faham tak? And then kita dah jadikan this one is leading one. Okay, this value we need to make a 0 value. So nak jadikan dia 0, kita tengok pada leading one atas dia saja. Okay, bukan pada row 1. No. Okay, we need to make a 0 value, tengok pada yang atas dia. Okay, leading one yang atas dia, which is row 2. Okay, so because of this is positive 3, therefore negative 3 multiplied with row 2 plus row 3 equals to the row 3. Okay, so row 2 we need to multiply with negative 3. So negative 3 times 0 we get 0. Negative 3 times 1 we get negative 3. Negative 3 times negative 5 we get 15. Okay, negative 3 times 0 you get 0. Plus with row 3. So 0, 3, negative 2, 0. 0, 3, negative 2, 0. Then you need to solve. This is 0, negative 3 plus 3 you get 0. 15 minus 2 we get 13. And then this is 0 equals to the row 3. Okay, so we got the new value for row 3. 1, negative 2, 2, 0, 1, negative 5. This one is 0, 0. And then row 3 is 0, 0, 13, 0. Okay, so kita dah jadikan this one is 0. The last one for this value 13, we need to make a leading one. Okay, as this one. Okay, we need to make a leading one here. So row 3 divided by 13 equals to the row 3. Okay, why divided by 13? Because 13 divided 13 we get 1. Okay, so 1, negative 2, 2, 0, 0, 1, negative 5, 0, 0, 0, 1, 0. Then we have transformed into row echelon form here. Okay, we have transformed into row echelon form here. Then we need to, okay, the solution to the system is found by back substitution. What it is mean by back substitution? It means we need to make a linear equation back. Okay, pada asalnya soalan asal it is linear equation, and then we need to transform into augmented matrix. After we have done into row echelon form, then we need to make a linear equation balik. Okay, back substitution. Okay, the name is back substitution. So we know that this is x1, x2, x3, right? So for x1, tengok pada leading one. Okay, leading one. Okay, saya buat kat sini lah. This is 1, negative 2, 2, 0, 1, negative 5, 0, 0, 1. This is 0, 0, 0. So, tengok pada sini. Okay. So, kita tengok pada leading one. This is x1, x2, x3. So, x1, okay, the value is 1. x2, the value is negative 2, x2. x3 is, okay, this because of this is positive, so plus 2x3. It is equal 0. Okay, this is first equation. Second equation, okay, kita ada leading one juga kat sini, second equation. So because of x1 is 0, so no need to put x1. Okay, starting with x2. So the value is 1. So x2 negative, okay, negative 5x3. That means minus 5x3 equals to 0. This is second equation. Okay, and then last one, x3. Okay, x3 equals to 0. This is third equation. Since we know that x3 equals to 0, Okay, x3 equals to 0. Then we can substitute into second equation to get the value for x2. So x2 minus 5 times 0 equals to 0. Therefore, x2 equals to 0 also. Since we know that x2 and x3 is 0, then we can substitute into the first equation to get the value for x1. Okay, so x1 minus 2 times 0 plus 2 times 0. It is equal 0. Therefore, x1 equals to 0 also. Okay, so we have the value here, x1, x2, x3. It is equal 0, 0, 0. So this is the answer. Okay, this is we call as Gaussian Elimination Method. Okay, Gaussian Elimination Method. Okay, you faham now? So this is for question A. What about question B? Okay, question B, look at question B. Okay, from the linear equation, we need to transform into augmented matrix. Okay, into augmented matrix, which is 1, 4, negative 3, 4, 16, negative 12. Okay, and then negative 3, negative 12, 9. And matrix B is 0, 0, 0. Okay. So we need to make this value 0. Okay, we need to make this value to be 0 value. Then this one we need to make a leading one, 16 and 9. So the first step is, because of this is positive 4 here, so we put negative 4 multiply with row 1 plus row 2, it goes to the row 2. And then because of this is negative 3, so positive 3 multiply with row 1 plus row 3 equals to the row 3. Okay, and then you need to calculate. Okay, so negative 4 times 1 we get negative 4. Okay, negative 4 times 4 we get negative 16. Negative 4 times negative 3 we get 12. Negative 4 times 0 we get 0. Okay, and then plus with what? Row 2. 4, 16, negative 12, 0. 4, 16, negative 12, 0. Then we need to solve. Negative 4 plus 4 we get 0. 16 plus negative 16 plus 16 we get 0. 12 minus 12 we get 0. And then this is 0. So this is equals to the row 2. Okay, and then second operation. Row 1 we need to multiply with 3. Okay, 3 times 1 we get 3. 3 times 4 we get 12. 3 times negative 3 we get, you nampak dah? So 3 times negative 3 we get negative 9. 3 times 0 we get 0. Plus with row 3 which is negative 3, negative 12, 9, 0. Okay, so 3 minus 3 we get 0. 12 minus 12 we get 0. Negative 9 plus 9 we get 0. This one we get 0 also. So it goes to the row 3. Then we have new value for row 2 and row 3. 1, 4, negative 3, 0. For row 1 it is fixed value. So for row 2, 0, 0, 0, 0. For row 3, 0, 0, 0, 0. Okay, then habis dah. Okay, kita tak boleh nak proceed dah. Okay, sebab kat bawah ni second row and third row all 0 value. Okay, then we need to use a back substitution. Okay, back substitution. That means we have a leading one here. X1, X2, X3. So the leading one ni, that means it is leading variable lah. Okay, X1 plus 4X2 minus 3X3 equals to 0. Okay, so from this answer, okay, yang ni belum final answer lagi. Okay, sebab kita tak tahu x2 and x3. So, how do you want to find the x2 and x3? Okay, x1, x2, x3. So, because of x2 and x3 it is 0 value, so we can declare x2 and x3 as free variable. Okay, as free variable. Okay, we can declare x2 and x3 as free variables, but x2 and x3 it doesn't have leading one here. Okay, so kita declare x2 and x3 as free variable. So free variable, that means x2 we can declare, we can let as t, let's say. Okay, I'm gonna let x2 for t, okay, where t, it can be any real number. Okay, and then I will let x3 equals to s, where s, it can be any real number. Okay, that means we can let any numbers here for t and s. Okay, because of x2 and x3 is free variable, so we can let any numbers for value t and value s. Okay, since x2 is t and x3 is s, okay, therefore we can find the value for x1. Okay, that means x1 plus 4, x2 is t, minus 3, x3 is s. It is equal 0. So therefore x1 it is equal, okay, kita jadikan x1 sebagai subjek, so it will be 3s minus 4t. So the answer would be x1, x2, x3, it is equal, x1 is 3s minus 4t, x2 is t, and x3 is s. So this is the answer. Okay, so this is we call as infinitely many solutions. Okay, infinitely many solutions here. Okay, why infinitely many solutions? That means we can check, we can test. Okay, we can check, we can test a particular solution. Okay, we can test, okay, a particular solution because of x2 and x3 free variable. Okay, I have done let x2 is t, x3 is s. So that means we can let any numbers here. Let's say I want let s equals to 1 and t equals to t. Okay, we know that x1, x2, x3 it is equal 3s minus 4t and then t s. Okay, yang ni value dia. Okay, so when we let s equals to 1, t equals to 1, so substitute into this value. Okay, it is equal, when s equals to 1, 1 times 3 we get 3. Okay, when t equals to 1, 1 times 4 we get 4. So 3 minus 4 we get negative 1, right? And then t is 1, s is 1. Okay, s is 1 here. So this gonna be a solution to the system of linear equation. Okay, we need to test to check. Okay, based on equation from question B. Okay, we know that this is x1, x2, x3. Then try substitute into this linear equation. Okay, kalau awak substitute, okay, awak calculate dapat tak equal to 0. Okay, tengok pada equation ni. Okay, negative 1, 1, 1. Okay, x1 is negative 1, x2 is 1, x3 is 1. Substitute into this equation. Okay, try first equation. Okay, substitute. Dapat tak equal to 0? Okay, kalau tak dapat, that means we need to test another variable here. Another value here. We need to test another value. Okay, kalau dapat equal 0, that means negative 1, 1, 1, it is the solution to the system of linear equation. Okay, kalau dapat equal to 0. If tak dapat, that means we can try any numbers. Okay, when s equals to 2, t equals to 3, then we need to check whether this is a solution to the system of linear equation. Okay, but this one saya tunjuk contoh saja. Okay, saya tunjuk contoh saja. No need to calculate. Okay, the final answer it will be this one, 3s minus 4t ts. Okay, tak perlu buat yang ni pun tak apa. Yang ni saya just nak explain saja. Okay, you faham nak? Tak faham boleh tanya dalam WhatsApp. Okay.